Hello students, hope you are doing well and you have followed the previous videos of physics as well as other subjects on Get My Classes. In this video, we'll look into the other topics of the chapter Waves and Sound. The topics that we are going to look into are wave speed. We'll try to understand what do we mean by wave speed, particle velocity, the velocity of the vibrating oscillating particle, medium particle in a wave, and speed of transverse pulse in a stretched string. Now let's try to understand what is wave speed. Wave speed is the speed of the wave, or speed of the wave is given by distance by time. Now how do I calculate distance by time? It is just the ratio of the wavelength by the time taken to cover that distance of the wavelength. Now time taken for one complete oscillation is time period. So I can say wave speed, or the speed with which energy is transferred from one point to other point by a wave, is the ratio of wavelength and time period. So time period is the total time taken for one oscillation. Now what about particle speed? Now in order to get the expression for particle speed, it is the speed of the particle in the wave, which is generally simple harmonic. If I am taking a harmonic wave, then the speed of the particle is simple harmonic in nature. Now if I take a general equation of wave as y equal to a sine omega t, I am taking this as equation of a wave, a sine omega t plus or minus, I'll say kx. Then velocity of the particle can be given by dy by dt. If I find dy by dt, I'll get how much? It is a sine omega t is omega and cos of omega t plus or minus kx. This is what is. So here this is velocity of the particle. Now this part is what it is, the maximum velocity of the particle. So velocity of the particle depends on various parameters like the time and all those things. So when it is at mean position, it has maximum velocity. When it is at extreme position, it has zero velocity, and so on, because it moves simple harmonically. So this maximum velocity, particle velocity, is equal to omega into a, where omega is the angular frequency and a is the amplitude of the wave. So going ahead on the particle speed, the same explanation that I tried to do. If I take an expression y equal to a cos omega t plus or minus kx, then particle velocity v is given by dy by dt. That is equal to, a omega sine of omega t plus or minus kx. Here there would be a negative sign. So from this, I'll have velocity of the particle at any given time is minus a omega into sine of omega t plus or minus kx. Now this is the maximum particle velocity. So this is how we calculate the particle velocity and wave velocity. So when a question is given, be very sure which velocity is asked. Now let's look at speed of wave pulse produced on a string. Now let's say if I produce a wave, it's a common experience that we have, the pulse would be moving, from the point where it is produced to the other end of the string. Now how do I calculate what is the wave speed of the pulse on a string? I'll just try to magnify this picture. Let's say this is the part of the pulse which is almost circular in nature. I'll see what are the forces acting on it. Now tension T is trying to pull it downwards. So I'll take a very small part of this, let's say, which subtends an angle 2 theta. I'll just take it. This is theta and this is theta. Now in that case, what will happen? If this is theta, this would be theta and this would be theta. So this side, component of tension acting in this direction is T sine theta, and this direction is T cos theta. So similarly here also I can write this to be T cos theta and this to be T sine theta. Right. So the net force which is trying to pull the string back to its original position is 2t sine theta. I can say restoring force is 2t sine theta. And the force which is trying to pull it up is mv square by r, where r is the radius of this part. So I can say it is force which is pulling out is mv square by r. So I can equate these two forces. I can write 2t sine theta equal to mv square by r. Now what is m? M equal to mass per unit length into length of the strip. Now L can be written as r into 2 theta because it subtends an angle of 2 theta. So that would give me 2t sine theta equal to m is mu into L, v square remains v square into r into 2 theta, sorry, instead of L I'll write r into 2 theta by r. So r cancels, I can cancel even 2 and 2. So I'll just do it here. So from this I'll be left with t sine theta equal to mu into v square theta. Now for small angles, when theta tends to 0, sine theta tends to theta. If I substitute it here, I'll get t theta equal to mu into v square theta. Theta theta cancels. I have v square equal to t by mu, or p equal to square root of t by mu. So the speed of a transverse pulse produced on a string is root t by mu. So we have v equal to root t by mu. So again, what does that mean? V depends on, I can say V is directly proportional to square root of tension in the string. So if more tension is there, then the speed with which the pulse transferred is more. And V is inversely proportional to square root of mu, that is linear mass density. Greater linear mass density would mean lower speed of the pulse. So these are the two parameters on which speed of transverse pulse produced on a string depends on. So this is what is there in this particular video. So let's have a quick review of what all things we have done. We have seen what is wave speed. Uh, we have seen what is particle speed, and then we have found expression for. So we have seen what is the expression for speed of wave transverse pulse that is produced in a string. So the transverse pulse speed only depends on the tension in the string and the linear mass density. One important thing is it does not depend on mass per unit length. Hope you could follow everything that we did. Thanks a lot for watching this video, and keep watching other videos of Get My Class. Thank you very much once again.